So we're going to be looking here today at another way that we can graph linear equations, and that is in slope-intercept form. So we'll talk a little bit about what slope-intercept form means and how it's a really easy way to graph equations. Okay, so slope-intercept form is an equation in a very specific form. Okay, it's where we have the y value equal to the rest of the stuff. So the format is y equals mx plus b, right, with m being a coefficient of x. Now, a couple parts here. When it's in that form, that m, okay, whatever that coefficient is of x, that's going to be your slope. And we'll look at a couple examples here just to show you that. And then b, the number at the end, is the y-intercept. I understand it says plus b, but again, that could be a plus negative. So, you know, if you had like, a couple examples of that, like y equals 2x plus 3. Okay, that's in slope-intercept form. We've got our m in this case would be 2, our b would be 3. Right? I could have negative 1/2 x minus 2. Okay, so there's your m. And again, this says plus, but we know subtraction, we can change to plus negative. So your slope would be negative 1/2, your y-intercept is negative 2. And we've looked before at how easy it is to graph lines if we have those two pieces of information. Okay, now let's look at just a couple of graphs here that I've put onto Desmos. So I've got y equals 2/3 x minus 2 is the red one there. Zoom in just a little bit, and y equals negative 2x plus 2 is the blue one. There we go. All right, so if we're looking at a couple things here, again, our y-intercept. So our red one has a y-intercept at negative 2, and we can see that on our graph. Right? Our blue one has a y-intercept of plus 2, and we can see that on our graph there. So that number that you're adding or you're subtracting at the end is your y-intercept, right? It's where it hits your y-axis at. And again, if it's minus, remember, treat that as a negative. So minus 2 is a y-intercept of negative 2. And then we can look at that slope, right? So in our red one there, the slope is positive 2/3, and we can see that from the graph. All right, if I pick those 2 points there and I calculate my rise and my run, right, to calculate slope, so I would go up 2 and I would go right 3, right? So we can see that slope of 2/3 right there in the graph, okay? For my red one, get rid of some of this stuff here. Oops, there we go. For the red one, again, I'm sorry, the blue one. Let's do the blue one. I already did the red one. The blue one there, y equals negative 2x plus 2. So again, there's our y-intercept of positive 2. Okay, and our slope is negative 2, right? So negative 2 over 1. So we can see that on our graph here. Okay, there's our rise of negative 2, our run of 1. Right? So we can see where on the when the equation's in slope-intercept form like that, it's really easy to identify the y-intercept and the slope. Right, because it's in that format. Again, that last number tells you your y-intercept, the coefficient of x, the number in front of the x tells you your slope. Okay, so let's say I wanted to graph an equation in slope-intercept form. Super, super simple. Let's say I had y equals 1/2 x minus 4. Okay, so I simply need to identify the slope. So the slope, again, is the number in front of the x. So my slope in this case is 1/2, and my y-intercept is going to be the number at the end. And again, there's a minus sign, so we've got to pick that up, right? That's a negative. So my y-intercept is at negative 4. Okay, so if I want to graph that, I simply have to plug my y-intercept onto the graph. Right there, 0, negative 4. And my slope is 1/2. Remember, rise and run. So I'm just going to count from that point. I'm going to go up 1, right 2. I'm going to do a couple more just to make my line a little bit straighter. Yep, and then I can draw my graph in there. Draw my line. Okay, so it would look like that. Right? Super, super simple. Let's do one more. Get rid of this stuff here. Let's say I had this time a negative slope. So let's say I had right here y equals negative 3/2 x. Let's go plus 3. So again, my slope is that number in front of the x. And my y-intercept is at 3. Okay, so I want to graph that. Just put my y-intercept on there. 0, 3. Okay, my slope is negative 3/2, so I'm going to go down 3 and right 2. Or I could go up 3 and left 2. Just have to make one of those negative. Oops, I missed my dots, but you get the general idea there. Okay? Again, super, super simple slope-intercept form to graph because we've got all the information there that we need. Now, sometimes equations aren't written in slope-intercept form, so sometimes we have to solve them. For example, let's say I had something like 2x plus 3y equals 5. Okay, and I wanted to get that into slope-intercept form. All right, so essentially what I'm doing there is I'm going to solve for y, right? So if I think about doing that, I've got to take that 2x, I've got to move it to the other side, and since it's positive, I'd subtract it from both sides, right? So it gets rid of it from the left side and puts it on the right side. And again, always list your x first. So negative 2x, and since 5 is positive, plus 5, and then divide by 3. Okay, so I'd have y equals negative 2/3 x plus 5/3. Okay, so I have my slope, I have my y-intercept. I could graph it from there. Let's do one more of those. Let's say I had 8x minus 4y equals 12. Okay, so again, I want to move my 8x over, so I'm going to get rid of it from this side by subtracting. Okay, so that would cancel that out. Again, we've got a minus sign there. We've got to make sure we drop that down and make it a negative. And then I've got negative 8x plus 12. Remember, these aren't like terms. I can't combine those together. Okay, I just brought my 8x over. And then I want to divide by negative 4. Again, you got to divide everything by negative when you divide. So divide everything by negative 4. Right? And that's 1y. Negative 8 divided by negative 4 is positive 2. 12 divided by negative 4 is negative 3. Okay, so I'd have y equals 2x plus negative 3. I know my slope. I know my y-intercept. I could graph it from there. Right? Be careful. Like if you have a negative here, so if I had like negative 3x plus 4y equals, let's say 16. Okay. In this case, when I want to move the 3x, it's negative. It's going to make sure you add. Right? All that stuff we learned about solving equations and moving things still applies here. So that would cancel that out. I'd have 3x plus 16. Divide everything by 4. So 1y, 3, and again, I'm going to keep that. I want to keep that as a fraction because we want the slope. Slope's a ratio, so don't change it to 0.75 or anything like that. 16 divided by 4 is 4. Okay, and I could graph that. I know my slope. I know my y-intercept. Okay, I could graph it from there. All right. Now, a couple other interesting things. Let me get this back up here. Really quickly, we're going to look at parallel lines and then perpendicular lines, okay? So if you think about parallel lines, if I have a line and I want to keep the other line parallel, it's got to go at the same angle. So parallel lines have the same slope. So let me put a couple of parallel lines in here. So y equals 2x plus 3. So to make it parallel, I have to have the same slope. So I'm going to keep the 2x, and I'm just going to change my y-intercept. Let's just make it minus 2. Okay. All right. So I can see there, Those lines are parallel, right? They're running in the same direction. They don't touch. They just have different y-intercepts, okay? So if I want to come up with a parallel line, or I'm determining the lines are parallel, parallel lines have the same slope. They have the same slope, okay? Perpendicular lines, those are lines that form at 90-degree angles. If we think about perpendicular, if I want a perpendicular line to this, right, I want it going, let me grab my pen here, I want it going kind of the opposite way. Oops. Right, so I want it to be negative. And then if you notice on this one, it kind of has a large rise and a small run. This one's kind of the opposite, it has a small rise compared to its run, okay? My slope is 2, okay? I write that as a fraction. So I'm going to do the opposite reciprocal. So I'm going to make it negative, and instead of 2 rise, 1 run, I want it reversed there. So 1 rise, 2 run. And we'll look and see what that does. There we go. So y would equal, instead of 2x, I do negative 1/2 x plus, just pick a new y-intercept, doesn't really matter, let's just do 1. Okay. So if I look at that, right, there's my right angle. I know that those are perpendicular to each other. Okay. So let's just kind of summarize that here. All right. So parallel, same slope. You can have a different y-intercept. Okay, if it's the same y-intercept, it'd be just a line on top of each other. Okay, so parallel is the same slope. Perpendicular is going to be the opposite reciprocal. Right? So parallel, you might have like y equals 1/2 x plus 2, and y equals 2/3. Oh, what am I doing? Let's try that again. 1/2 x minus 3. So I have the same slope. Perpendicular, let's say I had y equals 3/4 x minus 2. Right, the opposite reciprocal, so I'd make that negative, and then reciprocal 4/3 x and whatever y-intercept plus 5, something like that. Okay, so parallel, same slope. Perpendicular is the opposite reciprocal. And then if I gave you a problem something like this, if I said like let's say I had a equation that was y equals 2x minus 3, and I said give me a parallel line, let's say through let's say 0, 4. Okay, well parallel tells me my slope is going to be the same, so 2x, and this point is on the y-intercept. Since it's positive, I do plus 4, so that'd be a parallel line through that point. Okay, if I wanted to say a perpendicular line, I'll start that same one, y equals 2x minus 3, and I wanted a perpendicular line, and let's say I want it through point 0, 4. Okay, well perpendicular tells me my slope becomes the opposite reciprocal, so 2 becomes negative 1/2, right? 2/1, we flip that around and do the opposite, and then this is my y-intercept, so it's going to go through positive 4, so plus 4. Okay, so again, parallel, same slope. Perpendicular, opposite reciprocal, right? When you are putting things into, or looking at slope-intercept, again, that number in front of the x, that's your slope. Okay, the number at the end, that's your y-intercepts, right? So when we want to graph that, we just plot our y-intercept, use our rise and our run to find our next couple of points. Okay, super easy to graph. All right, slope-intercept form.